transmission media, and antenna system. The topic that I will discuss to you is fiber optic connectors. So, what is fiber optic connectors? The fiber optic connectors has several functions. It aligns with the fiber, with the emitters, in transmitters, adjacent fibers in splices, and photodetectors in receivers. With the development of various connector styles, each one has its own advantages, disadvantages, and capabilities. All fiber optic connectors have four basic components, which are the ferrule, connector body, cable, and coupling device. Fiber optic connectors align two fibers end to end so precisely that light can travel from one fiber into another without bouncing off the interface and lost its signals. Besides, fiber optic connectors provides cross-connect and flexibility for the telecommunication network, so a complicated computer network could be able to modular and easy to manage. Just like any other connectors used in electric industry, electronic industry, and computer industry. Many different kinds of fiber optic connectors were invented and development of fiber optic communication industry. The first type of connectors is the standard connector or SC. Simple, rugged, and low-cost SC connectors use a ceramic ferrule to deliver accurate alignment of the SMF. The SC connector comes with a locking tab that enables push-on or pull-off operation at the time of writing. Most popular choice for such equipment like fiber multiplexer, GPON, and EPON, ONUs, and fiber media converters and more. Due to its excellent performance, it dominates fiber optics for over a decade with only the ST rivaling it. 30 years on, it remains the second most common connector for polarization and maintaining the application. The SC is ideally suited for datacoms and telecoms application including point-to-point and passive optic networking. Second is the ferrule connector or FC. Although the FC connector was widely used in fiber optic networks until of the late, its use in dwindling fast. This connector uses a threaded container and a position locatable notch to achieve exact locating of the SMF in relation to the receiver and the optical source. Once the collector is installed, its position is maintained with a total precision. Initially intended for datacoms and telecoms application, its use has reduced since the introduction of the SC and LC. This delivers similar to the performance to the FC, but both have less expensive components and are quicker to connect. However, the screw-on collet of the FC does make it particularly effective in high variation environment, ensuring that the spring-loaded ferrule is firmly mated. Next is the ST connector. The ST connector's keyed bayonet design is similar to that of a BNC or the bayonet nut collector or the bayonet Neal-Colsman connector. The connector is widely for MMF, SMM, FOC, and is extremely used. The ST connector is manufactured in two versions, the ST and the ST2. Both types are keyed and spring-loaded and use a push-in and twist mechanism. It is typically installed in infrastructure that were built at the turn of the century, when retrofitting ST are typically swapped out for more cost-effective SC and LC connectors. Next is the lucent connector or the LC. The lucent connector, sometimes referred to as a little connector, is a small form of factor of FOC that uses a 1.25 mm ferrule. There are three types of LC connectors. First is the single mode LC APC, next single mode LC UPC, and the multi-mode LC UPC. Having half the footprints of the SC connector gives it huge popularity in datacomms and other high-density patch applications, as its combination of small size and latch feature make it ideally for densely populated racks panels. With the introduction of LC compatible with transceivers and active networking components, its steady growth in the fifth arena is likely continue. Is the empty connector. The empty connector is a ribbon cable that has 12 fiber connectors. They are used for factory terminated cable assemblies and cabling system. Multi-fiber connectors are not currently designed for field fit application, so must be lab terminated. In high-density patch environments such as data centers, they are used extensively both at single-mode and multi-mode wavelengths. However, as might as expected, the attenuation loss can be higher than a single ceramic ferrule connector. That being said, it is possible to order low-loss MTP, MPO connectors which have comparable insertion loss performance. Next is the bionic connector. The now obsolete bionic connector was one of the first connectors employed in fiber optic communication links. This connector can be easily identified by the tapering sleeve that fixes onto the fiber optic connector. The narrowing end enables the sleeve to be located on the connector properly. The connection is secured by the guided rings that are provided completely with caps. The connection is secured by guided rings that are provided complete with caps. These fit over the ferrule and screw onto the sleeve that is threaded. SMA connector. The obsolete SMA connector was the forerunner to the ST connector, which we discussed above. This connector was eventually replaced by ST and later by SC connectors. Next is the plastic fiber optic connectors. There are relatively fewer plastic connectors available when compared to glass fibers. These connectors are cheaper and are primarily designed for easy application. Polish and epoxy options are generally not available for plastic connectors. Plastic FOC connectors are available in both standard and proprietary design. Although SMA and or ST connectors are mainly designed for use with glass, they can also use with plastic FOC. Enterprise System Connection Connector or the SCON. SCON connectors were deployed by IBM for interfacing peripheral storage devices, including tape drives, to their mainframes. SCON is a half-duplex serial interface that uses FOC. Next is the Fiber Distributed Data Interface Connector or the FDDI. FDDI provides data transmission at 100 Mbps in a dual ring token local area network within a 200 km range. The FDDI connector connects the network equipments to a wall plug. The connector contains a 2.5 mm ferrule that can mate onto ST and SC connectors by making use of adapters. Next is the optic jack connector. The optic jack connector duplex connector resembles the universal RJ45 connector. The package contains two ST-type ferrules and the rug plug and jack female and male connectors. Next is the LX5 connector. The LX5 provides high density with performance and reliable connection. The connector uses automatically metal shutter technology in a standardized small and form package with a 1.25 mm ferrule. Next is the Volition connector. The Volition connector is unique in that it does use a ferrule. This plug-and-jack duplex connector employs the V-shaped groove to align the fibers. Next is the MTRJ connector. The single polymer ferrule duplex MTRJ connector includes the alignment. It's available in female, male connectors or a plug-jack format. Next is the MU connector. MU connectors have reduced footprints and are new generation connectors used mainly in dense application, and the connector is square and employs the push-pull mating mechanism. Next is lastly, the E2000 connector. Modern day telecommunication networks increasingly makes use of E2000 connectors. The inclusion of an integrated spring-loaded shutter is a unique feature of this connector. It protects the ferrule from dirt, dust, and scratches. As this connector uses a monoblock ceramic ferrule, problems associated with different coefficient of expansion are eliminated. The E2000 is a latch, pull, and push locking connector. The E2000 is trademarked by Diamond SA based in Lausanne, Switzerland. These are the sample questions from the topic, the fiber optic connectors. First question is, which is the following is the proper definition of fiber optic connectors? A joint between two fibers, a joint between two fibers that can be disconnected, a device attached to a fiber that terminates it for mating to other fibers or transceivers. Lastly, the temporary splice. Second is that the quality of fiber optic connector depends on its blank, loss reflectance, reliability, or all of the above. Third, most fiber optic connectors use blank ferrules to hold the fiber because it best matches the glass fiber's properties: aluminum, stainless steel, thermoplastic, ceramic. Fourth, the single fiber optic connectors cannot be said to have loss. Loss is defined as slight loss when two connectors are mated to create a joint between two fibers should be described as connection loss. True or false? Lastly, which is the correct term to use, connector loss or connection loss? Connector loss, connection loss, it's either is okay. What is the difference? These are the answer for the sample questions. Thank you.